Hello everyone, welcome to JNCC Science Talks. Today it's myself and Charlie on technology, and we are talking with Ivan Hernandez from the University of Gibraltar. He's carried out a comprehensive case study using high-resolution video data from 2017 surveys in the Southwest approaches to determine litter density, and I'm hoping he will speak now.
Hello, everyone. Thank you very much for attending. I appreciate it's your lunch break, so I'll try and be as brief as possible and hope you find it as interesting as I did in doing this project. This project was about marine litter in submarine canyons with a case study on the Southwest approaches, specifically in the canyons MCZ. So, okay, so in order to do this, well, first of all, marine litter, as you probably all know, is a ubiquitous problem. You can find it everywhere and anywhere at all depths. And it doesn't really matter how near or far you are from a densely populated area, you will find marine litter in some way or another. And it presents much bigger problems to the environment than just mere aesthetic concerns. There have been a lot of studies on marine litter on beaches, floating marine litter, and also in coastal environments, but little is known on the impact of marine litter in deep sea environments. And one of these deep sea environments is submarine canyons, which are, very interesting because they're considered to be keystone structures. They provide goods and services essential for the survival of many species. They're also biodiversity and biomass hotspots, and they're also considered to be preferential conduits for the transport of sediments and organic matter. They connect the shallower continental shelf with the deep sea basins or the abyssal plains, but these transport processes are also responsible for transporting marine litter into submarine canyons, which can have quite bad serious effects. And for these reasons, submarine canyons are also considered to be passive accumulation zones for marine litter. The thing is, within submarine canyons, there are vulnerable marine ecosystems, which means that they are very highly impacted by anthropogenic effects, and they have low resilience and low adaptivity. So in order to see where the state of the research is with regards to marine litter in deep sea environments, I conducted a literature review and critical synthesis. And in order to do this, I looked at I searched for the past 40 years, just from doing general reading. This was at the beginning of my project, so I did this back in February, and I used Google Scholar and Science Direct. And the keywords that I chose could be divided into two lexical groups. So the first one was, I chose habitats and features, keywords such as hydrothermal vents, seamounts, submarine canyons, and so on. And also marine litter related impacts, such as microplastics, plastic pollution, marine debris, marine litter, and so on. So when I looked at the results over the 40 years, the trends, I mean, the individual keywords are not really that important, because obviously we have a bit of a time constraint, but looking at the trend, we see that hydrothermal vents, really took off as from the early 90s. Seamounts, took off around the year 2000. And cold water corals, doesn't seem to be anything before the year 2000. And I didn't know it then, but I was then told that before then, before the year 2000, they were known as deep water corals, so that might be a reason. But cold water corals and submarine canyons follow a similar trajectory. When we look at the second group, which is for marine litter-related impacts, we see that there isn't that much before the year 2007. In fact, most of these search terms or keywords really take off as from the year 2013, 2014, especially microplastics. In the last few years, it has been quite exponential. There doesn't seem to be much for other terms such as ghost fishing or derelict fishing gear, but marine litter, marine debris, plastic pollution, they really have taken off in the last few years as well. The next thing I did was I combined all the different terms from the different groups, and I ended up with this matrix or heat map, and it shows the litter density. So the darker the red, the higher the litter density. And we see some hotspots around seamounts and also around deep sea floor and submarine canyons. But what's interesting is that hydrothermal vents that was showing the largest number of results in the previous stage, this time around only shows 0.4% of those results relate to marine litter impacts. And conversely, when we look at cold water corals, which was showing the lowest number of results, around 14% of these relate to marine litter impacts, which is the highest proportion. So in order to do the discovery process, I would have to analyze all these data sets. However, not all of them were relevant, and obviously, I was pressed for time. So I decided to concentrate on deep sea floor and submarine canyons. So the combinations are within the blue rectangles. And I chose all the marine litter impacts except for the microplastic related ones, because I think microplastics are a completely separate subject. So for the discovery process, I did a full analysis of the data sets of the chosen keywords on Google Scholar and Science Direct. Google Scholar is now rivals Web of Knowledge, so that is why I chose Google Scholar, and Science Direct only shows results behind a paywall, so it's not good to use on its own. But using both in combination proved to be very useful. So for the selection criteria of the papers I was then going to use for my literature review, I chose papers that had primary data on litter identification, classification, and quantification. I also included papers that had primary data on submarine canyons or the seabed, sea floor, and only of papers that had data on dives or trawls deeper than 50 meters, which isn't deep by any means, but then that meant that I could omit studies on beaches, estuaries, rivers and aquatic systems, floating or littoral marine litter. And then, like I said earlier, I omitted studies on microplastics. So a quick thematic representation. On the first level, I had combined results of about 275,000 from the two different lexical groups. Then when I joined them both together, I had around 7,500, which was reduced further to about 2,500 with the chosen keywords. And when I applied my selection criteria, I ended up with a corpus of 68. Now, if I had been super strict in only admitting papers that were about submarine canyons, I would have ended up with only 15. So that's why I decided to extend the criteria a little bit to also include papers that had data on the seabed and sea floor. So I had a little bit more to work with. And at the end of the day, the sampling methods and the identification methods would be very similar, if not the same. So then I proceeded to extract the data, and the first thing I saw was that 25% of marine litter studies had included data on submarine canyons. So even if they weren't exclusively on submarine canyons, some studies did include some submarine canyons, which was good. I then looked at the type of data that they used, and I saw that almost 47% used physical samples that they had dredged from the bottom of the seabed, and just over 53% used images of some sort, either photographs or video data. And this corresponds with the data acquisition methods. So around 49% used trawling, which corresponds to then retrieving the physical samples, and just over 51% used either drop fin camera, camera track, ROV, etc., other imaging technologies. When we look at the enumeration, so how that litter data is expressed, pretty much all of the papers that used trawling or samples also expressed it as weight. So for example, weight, kilograms per kilometer squared. And the rest, those that used images, tended to use frequency. So frequency, so number of items per kilometer squared or per hectare. However, those that used weight, about half of them, if not, yeah, just around half of them. Also, when I dig a little bit deeper into the results section of those papers, they also gave the data as frequency. Now, using frequency is, I'd say, is a lot more. The data becomes a lot more portable, and then it becomes much more comparable. You know, you can compare between different sites, and that type of data is more compatible with other studies as well. When you use weight, it's very limiting because those studies that use imaging, so either videos or photographs, you cannot determine the weight of an item of litter by looking at it on the seafloor. So I'd say, you know, using frequency would be the way to go. But there is very little standardization when it comes to how that frequency is expressed. For example, there were some papers that used items per kilometer squared, others items per hectare, but then there was some that used items per linear kilometer or linear 100 meters, which, you know, it becomes a bit useless in terms of being able to compare with other studies. And I think there were a few that even used things like items per 1,000 images. So, you know, items of litter per 1,000 images, which you can't really do much with that. The next thing I looked at was whether they recorded any interactions or impacts of the marine litter with the surrounding environment. And I saw that just over 70% didn't record anything. And just under 30% they did, but it was more of a checkbox exercise. So it's more like, yes, it's observed, you know, there is colonization or there is encrustment, but it didn't really go into any detail as to what that litter was doing. There was a handful of papers that did, but the focus of those papers was not the marine litter itself, but more on the species. So it does make sense that they would then be interested into what that litter was doing, you know, to the different species. But again, there's very little consensus as to how, you know, as to how the interactions are reported. And the thing is, you know, it's one thing to say how much litter there is, but I think you're missing the whole, you know, you're missing part of the story if you're not then if you're not then annotating or recording what that litter is doing to the surrounding environment. Then I looked at the litter classification systems, and this was a complete nightmare because they were all completely different. There were 2 papers, or 3% of them, that had no classification system, so they just said there's X amount of litter. Just over 57% said there was, you know, only use one level of categories. And almost 40% used 2 levels, so they would use categories and subcategories. But these were, you know, many times were not, you know, symmetrical. So not all the categories would then have subcategories. And I tried very hard for some time to come up with a statistical way of determining how similar or different the different papers were. In the end, I couldn't do it. I'm sure there must be a way, but, you know, at my level, I just couldn't quite do it. But what I did do during that exercise was standardize all the different litter classification systems for all the different papers. So I corrected, you know, for things like singular, plural, grammar, context, etc. Syntax, sorry, etc. And then I managed to come up with a chart which shows the most frequently used types of marine litter classification. So 25% of papers used artificial polymers, you know, all the different types of plastic categories, things like hard plastic, soft plastic, plastic bag, etc., etc. About 20% of them used a general category or miscellaneous, followed by metal, fishing materials, and so on. The thing is that there are some standardized litter classification systems in the established in protocols, which, you know, can be used for green litter in environments. It is interesting that more than 75% did not use any. Of those that did, the majority of them used MEDIT, which makes sense because there's a lot of studies in the Mediterranean. Less than 9% used the MSFD master list, and they didn't use it in its entirety. And it's interesting because they all, I mean, pretty much all the papers, they quote the MSFD because marine litter is one of the descriptors to achieve good environmental status by 2020, but very few papers actually used it as a marine litter classification protocol. And the least used one was OSPAR, which is the one that I've used as well for this particular project, and I know it's the one that you use at the JNCC as well. So with that said, I also looked at where these surveys have taken place, and I plotted them on, around the world on a world map. I'm going to show European waters in the next slide. That's why there's a box there, a blank box. But in all, there's 89 submarine canyon sites listed. Submarine canyons are in purple and seafloor sites are in red. To put it into context, there are 9,477 medium to large submarine canyons mapped. So 89, the fact that only 89 have been studied for marine litter shows that less than 0.9% have been studied in any way. If we look at, well, there's also, by looking at the world map, we see that there's two hotspots that are outside Europe. The first one is around Japan, and there's a lot of studies there looking at the effects on the seabed from the Fukushima earthquake and tsunami, and all the litter that dragged onto the seabed and into the trenches, and around the west coast of the United States, especially around the Monterey Canyon complex. If we look at the European seas, European waters, sorry, we see that there are quite a lot of studies around the Mediterranean Sea. And one interesting figure is that 92% of those submarine canyon sites are actually within European waters. And it shows the tremendous gap in the knowledge that there is on submarine canyons worldwide, when the vast majority of them studied are in European waters. We see that the hotspots for submarine canyons are between the Catalan coast and the Ligurian Sea, including the Gulf of Leon. Those are quite well-studied canyons. Canyons around Corsica, Sardinia, Sicily, and also around the coast of Portugal, the Bay of Biscay. And we see, two lonely purple dots just off the coast of Cornwall and Brittany, and that is the Whithard Canyon Complex and the Canyons MCZ, which is where this case study takes place. So I extracted a bit more data, but I'll show that later on. But this is a good segue into the case study. Now, this was a survey that was conducted, I'm using data from a survey that was conducted in 2017 in the Canyons MCZ, which is an area inside the Whithard Canyon Complex. And it is more than 300 kilometers away from from the nearest point of land. I've got the specs on the screen, but I won't go into them. There were 150 stations deployed in the Canyons MCZ, which you can see on the map as in the red box. And this comprised about 77 hours of footage to be analyzed. The average transit length was 276 meters, and the study was not really looking at marine litter. It was targeting broad-scale habitats only, and it was looking for diversity and structure of biological communities, typical species, to increase the biogeochemical understanding, extent distribution, physical structure, and organic composition from the deep seabed broad-scale habitats across the interflows, including cold water coral mini-mounds. If we look at the canyon area, we see, the Canyons MCZ area, we see that there are two canyons, the Explorer Canyon to the north and the Danguard Canyon to the south. The area between the two canyons is known as the Explorer Interfluve. The area south of the Danguard Canyon is known as the Danguard Interfluve. You can see that, from this diagram, not all parts of the canyons are covered. So on the survey, on the left-hand side, you can see, with the dots where the stations were. There were no stations north of the Explorer Canyon, so we don't have any data from the interfluve to the north. there is no data either from the areas around the canyon heads or around the canyon mouths, or where they connect to the eastern branch of the Whittard Canyon complex. So for the marine litter analysis, litter items are annotated using Beagle software. Now, for those who don't know what Beagle software is, like I said before, there was 77 hours of footage. I think there were about 153 different videos. And Beagle software is a web-based tool where you can import the video. You can have a customized classification list. In this case, it was about litter classification, but you can also use it, to identify species or different habitats or sediments. And so each video was watched and analyzed in its entirety. And when when I was watching the videos, I came across an item of litter. It was annotated by, stopping the video. That created a point in the timeline. I would choose the category from my category list, and I would then draw a polygon around it. And then what that does is that it allows you to create a point where you can then count how many items of litter you have in that video, in that transect, and also, what the different types of litter are. So the litter classification system I used was the one that's standardized in the MSFD from OSPAR. And the data that I retrieved from the videos was the timestamp, which is when it's recorded on the timeline, the type of litter that it was, and what that litter was doing to the surrounding environment, so any interactions. So I'm going to show you a few examples of what I saw. Now, on the bottom left-hand side, there is a piece of rope, which it looks like a filament, but it's actually a piece of rope. Then in this one, we see that there is another piece of rope, but this one, there seems to be contact, seems to be like snagged on a stone, and there seems to be contact with some organisms, with some anemones. In this picture, we see it's quite faint, so I don't know if you'll be able to see it on your screen, but this seems to be a piece of fishing line monofilament. It was quite difficult to distinguish between fishing line monofilament and rope. That's one of the main difficulties I had, because with the OSPAR litter protocol, there are no guides or examples as to what is what. So you have to come up with your own baseline and your own common sense, I suppose, and then figure out what you're going to consider to be an item, piece of monofilament, which in this case is a very thin piece of nylon, or what you're going to consider to be a piece of rope, which could be anything thicker than a piece of monofilament. Next, one of the other classifications was fishing line entangled. Now, this one seems to be entangled, but it could be a piece of rope. We don't, it's very difficult to know. But again, entangled in itself, entangled on a piece of rock, entangled on an organism, it becomes quite difficult to make those distinctions. And then there was one of the categories was rope, and the other one was synthetic rope. Now here we can see it's quite easily this is a piece of synthetic rope because of the color. It's purple, but again, there's no guidelines as to what is natural, what is synthetic. And this is an example of finding it difficult to determine whether it's natural or synthetic. This is deep down. This is in the deeper parts of one of the canyons. You can see to the right-hand side, there's like two pieces of rope hanging from the rocks. There also seem to be some corals there, but from the image, it's difficult to see whether it's is it purplish in color, is it brown, so it's very difficult to determine. Also, one of the other issues I had when looking at Beagle, or when using Beagle, was that I was initially going to look at photographs. So for each of the transects or each of the videos, there was also photographs that were taken. I think it was at 30-second intervals. But so at the beginning, I had like a bit of a Beagle training period of 1 or 2 weeks when I was getting used to seeing what was down in the videos and stuff, but I quickly realized that by watching the photographs, I was missing out on about 30% of the items of litter, which is why we then, as a team, decided to look at the videos in their entirety. So once all the videos were analyzed, I then plotted all the different densities, calculated the densities per transect on a map. I did this using QGIS, and there were a total of 1,038 items of litter per, for the total survey area, and this gave an overall litter density of 7,268 items per kilometer squared. Now, the standard deviation is very high. The standard error, not quite so much. But this is because there were, quite a few points or samples where there was no litter, and then there were others where, the litter density was extremely high. And we can see this. We can see that the highest litter density region corresponds to the Explorer interfluve. So when we look at the same data, but we plot this over the depth. And then attach the type of morphology, we see that there's 3 depth strata. The least deep one, it corresponds to the interfluves, the medium one, the flanks, and the deeper parts, the canyon floor. Also from the flanks, you can see that it extends over the 3 different depth strata, which I think created a bit of noise in the data for the multivariate statistics. However, we can see that the biggest outliers are in the interfluve regions. In fact, there was one sample point in the Explorer interfluve that had nearly 160,000 items of litter per kilometer squared, and there was quite a few, over 40,000, even 60,000. Now, to put that into perspective, the most polluted parts of the Mediterranean are around the Ligurian Sea, and one study measured 152,000 items of litter per kilometer squared. So this part, that point in the Explorer interfluve has more litter than the most polluted parts of the Mediterranean. Like I said, the flank transect spread throughout the different depth strata. And when we look at the data separated from what's inside the canyon and what's outside the canyon, we see that the Explorer interfluve has the highest litter density with about 20,500 items of litter per kilometer squared. But this is almost 4 times higher than that of the Dangarde interfluve. Also, the mean litter density in the interfluve areas combined is over 5 times higher than inside the canyons. And if we, dig a little bit deeper into that, we see that the Explorer interfluve has 5 times higher litter density than inside the Explorer canyon. The Dangarde interfluve has over 7 times higher litter density than inside the Dangarde canyon. And the Explorer canyon has over 5 times higher litter density than inside the Dangarde canyon. So within such a small area, really, the differences are quite large between different morphologies. And also there was no pattern between what was inside the canyon, so between orientation. So I was interested in seeing, especially whether there was any pattern between the flanks of the canyons, the north flanks and the south flanks. But in fact, what I found was that it's the south flank of the Explorer canyon and the north flank of the Dangarde canyon are the flanks that have the most litter density. And that is, coincidentally, they are the flanks that are adjacent to the Explorer interfluve that have the most litter density. So it could be that some of that litter from the Explorer interfluve is moving into the canyons, through those flanks. And another interesting point is that there is much higher litter density in the Explorer interfluve than in the Dangarde interfluve. Now, when you look at the amount of coral mini-mounds, which there was a paper by Stewart et al. From 2014, I think it was, and it said that there was, on the Explorer interfluve, there were 30 coral mini-mounds. In the Dangarde interfluve, there were between 350 and 400. Now, you think that, the more coral mini-mounds, the more rugged or the more heterogeneous the substrate would be, and that there would be more litter caught up, where the terrain was more rugged, but it doesn't follow that pattern. So this is this is where we see how the canyons MCZ fits in with other canyons. Now, this is data that I extracted from the literature review, which is really, that was the whole point, seeing, the litter density and compositions of other submarine canyons and then being able to compare it to this case study. So by looking at the canyons MCZ, we see that it is moderately high litter density, and it is actually higher than the Lisbon Canyon. So again, to put that into context, the Lisbon Canyon is just off the coast of Lisbon, and that is connected to the Tagus River, which flows through Lisbon, some densely populated areas, and one of the tributaries also follows through Madrid. So, it is a river system that, in theory, would carry quite a lot of litter down into the canyon. But the canyon's MCZ, which is over 300 kilometers away from land, has more litter than that canyon. Also, for this, in order to express the data within the canyons, there were several, this isn't just a case of one canyon per study. There was, one canyon could have had data from different studies, which meant that I had to then recalculate the different means in litter density and also the standard deviations, standard errors. And there was one previous study from a 2007 survey from the canyons from this survey area that was published in Pham et al. From 2014. That was from the 2007 survey, which is why I also have in red the Dangarde and Explorer canyons. So when I combined the data with the previous survey, it gave a litter density of around 3,800. So it was because that previous survey had recorded a lot less litter than in this 2017 survey. So next thing was looking at the composition of the litter. So this is the high resolution. So I looked at, these were, using all the different litter categories from the OSPA category list. But there were 4 different categories that, that had the greatest frequency, and they were composed of rope, fishing line monofilament, fishing line entangled, and synthetic rope. And these are all fishing gears, so that comes to 97.3% of all the litter in the canyons MCZ is composed of fishing gear. If we look at, take it as look into a lower resolution, so separate into fishing gear, plastic, metal, glass, and other, and look at what's outside the canyon and what's inside the canyon, there really isn't that much of a difference. It's still very much dominated by fishing gear. The Explorer Interfluve, it's almost 99%. The Dangarde Canyon has the least at 83%, but even that is, overwhelmingly a majority for fishing gear. So when we look at when we compare the different types of litter at a higher resolution, at a lower resolution, sorry, with other canyons, and again, this is data extracted from the corpus that I used for the literature review, we see that the canyons MCZ is the most affected by fishing gear, by a long shot. Really, there was no pattern between where the canyons were, if they were in the Mediterranean or in the Atlantic, in terms of whether they were more affected by plastic or fishing gear. But it is, the interesting thing is that, the canyons MCZ is the most affected by fishing gear out of all the canyons studied. Next, I looked at the interactions of litter items in the canyons MCZ, and I saw that, well, the vast majority, over 73% of litter items, there was no interaction as such. And of the ones that there was, the most frequent one was contact with an organism. Fortunately, I didn't see any examples of ghost fishing or breakages in terms of corals or anything like that. So the interactions didn't seem to be too bad. So mostly contact with an organism, as we saw in one of the pictures, caught in like maybe an anemone or a starfish, or many other times it was also caught on a rock or a stone. So the vast majority of litter was actually free, floating freely on the seabed, just drifting with the currents. And it makes sense that, when they encounter something, whether living or dead, that's where the litter will, just hang. But otherwise, it's just drifting. So for further analysis of the litter, I used Primer software to do some multivariate statistical analysis. I did the usual, shade plots, cluster diagrams, I did ANOSIM and SIMPA tests, NMDS, non-metric multidimensional scaling and bubble plots. And I also had to design, in order to do that, I had to come up with some factors. So I used canyon as a factor, because obviously we have 2 canyons within the survey area. Also, we had 3 depth strata, so I used that. I wanted to look at the orientation, especially of the flanks, as I mentioned earlier, and also the morphology, interflow flow. Now, one thing that became apparent was the disproportionate amount of samples that there are on the interflows. It was much, much higher than inside the canyons. That is the flanks and the canyon floor. And I think that was one of the reasons why some of the data might have been skewed. So because we're pressed for time, I'm not going to go into all the different R values and P values because I don't think that would be particularly interesting anyway. But just to summarize, from the ANOSIM tests, there were significant differences in the depth and the morphology groups, which I think we saw using the univariate analysis earlier on anyway. And the differences came between the 200 and 600 stratum and the 1400 to 1800 stratum. So, the shallowest parts and the deepest parts of the survey, which corresponds to the interflow regions and the canyon floor. When I did some SIMPA tests on the samples that were showing the significant differences, these were driven by the 2 most frequent types. So it was fishing monofilament and the natural rope categories. There were also significant differences when nesting depth within canyon, and also when I nested in the ANOSIM test morphology within canyon, and also morphology within orientation. However, I then realized that probably wasn't the best way to use orientation, because even though I wanted to look at the flanks, because all the other factors they looked at the survey area in its entirety. With orientation, then I ended up having to have like a north interflow, south interflow, north canyon floor, south canyon floor, etc. And I don't think I think that is the reason why that particular test didn't really work very well. But the main finding was that the inside areas of the canyons are significantly different from the outside areas of the canyons. So I mentioned cluster diagrams before, and the reason I didn't show them was because they weren't particularly conclusive. Now, in order to do that, I applied a log x plus 1 transformation to the data, because there was quite a large variance, from 0 to 160,000 items of litter per kilometer squared. I also I did a Bray-Curtis resemblance matrix, and it was 0 adjusted. As you see from these NMDS plots, the one on the left is for depth and the one on the right is for morphology. They're both very similar. Even though there's clustering at 60% similarity, there are different types. The different groups are within all the different clusters. So yeah, like the clustering diagrams, it's not it's not particularly clear. When I looked at the bubble plots for the 4 most common or most frequent types of litter, which made up 97% of the types of the composition of litter. These are mostly dominated by the interflow areas. The only one that isn't as much is synthetic rope, which seems to be found more in the flanks and in the canyon floor. That's the only one that stands out. So issues that I think I had with multivariate statistics was that the ANOSIM and SIMPA tests were not terribly conclusive. The cluster diagrams and the NMDS plots, again, were not very clear. And I think the number of samples on the interflows was disproportionately higher than the flanks and the canyon floor, and this could have been skewing the data. And that was apparent in the bubble plots, where you could see the dominance of the interflow areas. Also, that the factors were hierarchical and not truly independent. I think that may have had something to do with the fact that the Anderson tests were not, as clear as I would have liked. And I think the analysis is probably incomplete because, I think there needs to be data on the canyon heads and the canyon mouths and where they connect to, the eastern branch of the Whittier Canyon complex for a more complete analysis. And like I said, I think the further analysis is required, probably using Permanova. I think this will be done at a later date. So to wrap up, we saw that from the literature review, there were large gaps in knowledge with regards to marine litter and submarine canyons. There's a lack of standardization in the enumeration, quantification, and especially in the classification of marine litter. Also, we saw that the classification systems within the protocols are not being followed, and the interactions are not consistently reported on. And from the case study, we've seen that there's quite a high litter density in the canyons MCZ, especially in comparison to other canyons, such as the Lisbon Canyon, and that the litter density is dominated by the interfluve areas, especially the Explorer interfluve, and that the composition of litter is overwhelmingly from fishing activities. And that's this area, the survey area, is the most affected by litter than any other canyon area studied to date. And we've also seen that the marine litter, fortunately, does not tend to interact with the surrounding environment. Now, one last point I'd like to make about this is that I am aware that the canyons, the MCZ status was designated in 2014. And I said earlier that most of the litter was just, floating on or just drifting on the seabed. Now, I suppose, and this is just, me, thinking out loud, that if there had been bottom trawling, because I think bottom trawling was a problem some time ago, that, a lot of that litter would have been picked up by that activity. But the fact that, there is a lot of litter drifting, I would say maybe that, it is old litter that is just there, drifting with the currents. And we've seen that there are significant differences between what is inside the canyons and what is outside of the canyon areas. And that further multivariate statistical analysis is required, and inclusion of further data is recommended. So that's it from me, and thank you very much for listening, and I'm happy to take your questions.
Great, thanks very much, Ivan. For everyone who's still online, if you have any questions, please do type them into the questions or chat box. Thank you very much, Ivan. That was really informative and very interesting talk. I have actually already had a couple of questions come in, so we'll make a start on those while everybody else thinks about what they want to ask. So the first question that came in was there any grey literature included in the study? And were the evidence sections of the JNCC site information centres of relevant deep sea MPAs reviewed, for example, the canyons or Darwin mounds?
No, I didn't include grey literature. In my corpus of 68, I had 67 papers that were published and one PhD thesis. I did some, obviously further reading, but for the literature review, no, I didn't use any grey literature.
That's great. There was kind of a further part of that question about the evidence sections of the JNCC site information centres relevant to CMPAs, and whether those were reviewed.
I think I did come across them. I did get some information from the JNCC website regarding the Canyons MCZ area. Yeah.
That's great, thank you. The next question that came in was that the Canyons 2017 survey was very comprehensive. Did studies from other canyons have comparable numbers of sampling stations?
Okay, that's an interesting question, and that was one of the, I remember that was one of the discussion points I had from for my dissertation. Um, the problem, okay, so I extracted, data comparing the different litter densities from the canyons and the different litter composition that the different canyons had. However, one of the caveats, I mean, maybe I should have mentioned it earlier, was that there is no way of knowing where in the canyons that data was taken from. Now, in this survey area, like I said, it was very much dominated by the interflows. But in none of the other papers did they specify whether they included the interflows or whether they didn't, or where in the canyon, whether this was data from the flanks or the canyon floor. So it's very, very difficult to know, which is why, like in my dissertation, I say that these comparisons should be taken with caution, because a more direct comparison would be to compare only what's inside the canyons. But then again, there weren't that many samples from that, so it's very difficult to know.
And yeah, there was a further comment that JNCC datasets won't be in the study if grey literature wasn't used. I had a question by Skype just now.
Okay.
Earlier on when you were speaking about the classifications
Yeah.
regarding OSPAR and MEDIT, did you think of any reasons why people might not have used set classifications or otherwise? Or was it
As
just
why
a kind of,
as
sorry.
to why they use them. Well, it's impossible to know why they didn't use them. But I can speculate. I could speculate that probably either the classification systems are not, I mean, I know that obviously a lot of thought has gone into them, but by having analyzed, many hours of video using the OSPAR classification system, which is actually, I'd say, the better one of all of them, there are areas which I think could be improved. So it could be that these different studies, they might not think that the classification system is in the protocols are suitable for what it is that they are actually seeing on from their data. And another reason, I think I mentioned it earlier, was that the regional ones like MEDIT and OSPAR, they were designed to be used for trawling as a sampling method. Now, when you look at when you take submarine canyons, trawling is not recommended, or on the seabed we have protected species. So I think more studies are now looking or using imaging technology in order to look at marine litter. But the thing is, if you're using imaging technology, you might not think of using a protocol that was designed to use trawling as a sampling method, and to use how to look at physical samples of litter and how to classify them. So that may be one of the reasons, which is why I said that I think the deep sea community needs to look into this, because irrespective of geographical area or of what sampling method you use, I think there should be, or there could be, a standardized litter classification system that would make all these different studies compatible with one another.
Brilliant. Thanks very much for that insight. I've had another question about the litter. If litter is predominantly floating, do you believe there is any way to effectively manage the amount of litter entering the canyon's MCZ?
I think it's no. It's very, very difficult, because once litter is down there, you can't really do anything unless you go down physically and try and retrieve the litter. There's nothing really that you can use, and submarine canyons are the passive accumulation zones, and once something gets in, it will take a very long time for it to be released from the canyon into the deeper parts of the ocean. In fact, if it ever is. And the problem with marine litter is that if it is interacting with things like cold water corals, it can be damaging those organisms, and if it causes death to those cold water corals, then those items of marine litter would then be released again to damage other organisms. So unfortunately, no, I don't think that there's a way that you could manage the litter once it's inside the submarine canyons. The only thing that we can do is just reduce the amount of litter. And if the litter comes from fishing activities like we've seen in the canyons of CZ, then it would be a case of trying to stop all activities that cause the main cause of that littering in the first place.
Excellent, thank you very much. We had a further quick inquiry. The message says, thanks for the excellent presentation. Do you look to publish your findings?
Hopefully, that's something I'm very excited about. Hopefully we'll be writing a paper for the literature review that I did, and hopefully another one with the findings of the case study. However, I think there's further work that needs to be done on that, and possibly incorporate other data sets. I mean, the problem with one of the main problems I had was that I had to review, I was initially going to be looking at the photographs of the survey, and then when we decided I was going to watch the videos, that it took about, I think, almost 2 months in order to review all the videos. So then I didn't have enough time to incorporate. I was going to look at incorporating 2007 survey, and also I think it was another 2010 survey. So it would be good, for the publishing of a paper to be able to incorporate those, which have different parts of the canyon as well that were missing in this survey, to have a more complete view of the state of marine litter in this particular site.
Great, thank you very much. That all sounds very positive. So I think with that, we'll call it to a close, but thanks very much for your time and great presentation. And we look forward to seeing the was published. Thank you very much.
Thanks.
All right. Thank you.
Thanks. Bye. Bye.
Bye.